Exercise 9.3. We continue with the question number 26. You are given two numbers. Please read the question. Given numbers be these two. Given numbers be 3 and 81. What we want? We want two numbers between these two. So usually we call them as, here given number as A. We want this. This is 81. That is B. Right? This is a geometric progression. We find these two numbers, let me call G1 and G2, in such a way that this forms a GP. Now once this being a GP, if I want to get G1, I need to get the common ratio. So in this case the common ratio is given by, if you just recall, B by A raised to 1 upon n plus 1. Find what is n here, that is number of terms you want to insert. How many terms you want to insert? 2. So n is 2. Now just place the value. So 81 by 3 raised to, what will get here? 1 by 3. This is 27 raised to 1 by 3. So this is just 3. So therefore common ratio equals to 3. R equals to 3. Okay. Now you will get the G1. Therefore what is G1? That is A first term into common ratio, A into R. So it will be 3 into 3, which will be 9. What is G2? That's the previous term into R. That is 9 into 3, which will be 27. Is required numbers. These are the required numbers here. Okay? 9 and 27. Now let's go to next question, 27. Right. Such question we had in discussion of arithmetic progression. You want to get the value of n. This is the question. Get n. What is given? You are given that a raised to n plus 1, b raised to n plus 1 upon a raised to n plus b raised to n equals to, you have root AB. You are given that this is a geometric mean. Okay, because here geometric mean is root AB. We know it. Right? This is geometric mean, which is root AB. Now we need to simplify. How will simplify? One way is you can square it, so it will be free from the square root. And then I'll take this one over here. So a raised to n plus 1 plus b raised to n plus 1, the whole square equals to, this is free from the square root, AB. Here you have a raised to n plus b raised to n the whole square. You could have done without squaring also, but just for our simplicity I have squared it. Okay, now we expand this. What is this? Square. So power of the power gets multiplied. So 2 into this plus middle term, twice a raised to n plus 1 into b raised to n plus 1. Square of this, b raised to twice n plus 1. That is equals to, here I'll open the bracket and simultaneously I'll square it. So this is 2n. So a raised to 2n here plus 1 into b plus twice a raised to n, but because of this plus 1 into b raised to n, but because of this it is plus 1, plus what will be the last term here? B raised to 2n. B raised to here, what will get? The 2n. But once you take this is inside, plus 1, power will increase by 1 into a. Fine? This is simple algebra. I'm sure it's not a big task for us. Now you can see that this 2 middle term will get cancelled. Here you have 2n plus 1 power, here 2n plus 2 power. So we take this one on one side. And here 2n plus 2, 2n plus 1. So these two terms I'll take on the other side. Fine? We are just rearranging now. So let me rearrange. So here a raised to 2n plus 2 minus a raised to 2n plus 1 into b, that is equals to, on the other side b raised to 2n plus 1 into a minus b raised to 2n plus 2. Just observe as I explained in the previous step. Why we did this? You know very well, because now this much is common. A raised to 2n plus 1 you will find common. So here you are left with 1 power minus b as it is. Here b raised to 2n plus 1 you will find common. So you are left with a and here 1 power. So this will get cancelled. So a raised to 2n plus 1 equals to b raised to 2n plus 1. And therefore a by b, the whole raised to 2n plus 1 equals to 1. And therefore now, you know, if you have some expression raised to 0, then it has to be 1. Here you have 1, this is power expression. So this must be 0. 2n plus 1 has to be 0. And therefore n equals to, we have minus 1 by 2. Question number 28, that's good example. What you are given there, sum of two numbers is 6 times their geometric mean. Okay, so we start with two numbers. Let numbers be this. Let numbers be a and b. Okay, we want to show that the ratio of these two numbers, that is a by b, is that expression. Okay, and you are given this. What is given? Sum of these two numbers equals to 6 times their geometric mean, root ab. You know geometric mean is root ab for given two numbers. Now we will just rearrange like this here. What I'll do, out of 6, I'll take 2 over here with root, twice root ab, and here you are left with 3. Why I did like this, you will realize in few minutes. You see, here I'll write upon 1, that you can do. Now I'm going to use one concept that you might have studied earlier. If two ratios are equal, then you can do this: a plus b upon a minus b equals to c plus d upon c minus d. This is called componendo and dividendo, you know it. So I'm using this, two ratios are equal, therefore I'll add this expression, a plus b twice root ab. See, I've added this two upon, now I'll subtract b. So a plus b minus twice root ab equals to, now right hand side also, here you have 3 plus 1, I've added upon 3 minus 1. I've used this concept. Why I did like this? Now you look at it, left hand side expression. What is this? You can observe carefully. This is root a plus root b the whole square upon, what is this? Root a minus root b the whole square equals to, this is nothing but 4 by, you know, this is just 4 by 2, so that is 2. Fine. Now you can take the square root, just taking square root. So root a plus root b upon root a minus root b equals to root 2, taking square root. Now again I'll do the same thing because I'm interested to get what I want. I want this a by b. This is the question. I want this. Okay, so I'll use the same concept. Again the same concept. I'm adding this 2. So if I add this 2, root a plus root b plus root a minus root b upon root a plus root b. Now I'm doing minus this expression, root a, so this become plus root b equals to, I'll write upon 1. So what I'll get here? Root 2 plus 1 upon root 2 minus 1. You realize what I did? Is this clear to you? I've used the same concept, componendo and dividendo, CD rule. First I've added this expression, then I've subtracted this expression. Root 2 plus 1, root 2 minus 1. Now you see this will get cancelled, this will get cancelled. So what we are getting here? Twice root a. Here twice root b equals to root 2 plus 1 upon root 2 minus 1. Now you are interested to get what? A by b, you know. So this will get cancelled and I'll square it. So a by b equals to, here root 2 plus 1 the whole square upon root 2 minus 1 the whole square, by squaring. What I did? Just by squaring. Okay, now we'll just expand this. So this a by b equals to, if I expand this, 2 plus 1 which is 3 plus what's the middle term? 2 root 2. If I expand this, 2 plus 1 which is 3, what's the middle term? Minus 2 root 2. That's what you want. Right? Root. ratio should be this. Fine, clear? It's a nice question, little bit constructive solution, but anyway, there are some other ways also. Think over it. You can do it. Next, 29th is again just copy of this. See what is given? Arithmetic mean and geometric mean of two positive numbers are A and G. That's given to you. So we start with two positive numbers. Let two positive numbers be A and B. So therefore, what is A? You are given A plus B by 2, arithmetic mean. And what's the geometric mean? Which is root AB. Right? Arithmetic mean means what? A plus B by 2, and geometric means root AB. Okay. Now, prove that the numbers are this. So we want to show that A and B are this given expression. In short, you want A and B, right? That's a question. So indirectly, this is a question of solving these two equations. Here you can write 2A equals to A plus B, and G squared equals to, you have AB. What is the question? Find A and B. This is the question. So we need to use the elimination method. The one way you can do like this. See, here you have A plus B equals to 2A. So what I'll do, I can form A minus B if you remember. A minus B the whole square. It is A plus B the whole square minus 4AB. This is very standard algebraic identity. You just expand this, you will get equality. We have just added and subtracted middle term to make it A plus B whole square. I think this must be known to you. Why I did like this? Because I know A plus B. What is A plus B? That is 2A, so 4A square. Minus 4 times what is AB? That is G square. So I'm getting A minus B whole square equals to this. And therefore what is A minus B? That is plus or minus. This will be 2 root of A square minus G square. And therefore A minus B equals to plus or minus 2. Here you will get, this 2 factor, A minus G into A plus G. Now I'm sure you can do it. This is 1 about A plus B. I'll call this as 2 about A plus B. So these are the two equations about A minus B and A plus B. So solve for A and B. Solving for A and B. How will solve? Simply elimination method. Okay, so you will get the values of A and B, and these values must be what you are asked to prove. So try it. This much is for you. I'm sure you can do it. Okay, let's go to next question. Question number 30th here. What it says, let's read that. The 30th question. The number of bacteria in a certain culture double in every hour. Okay, if there was 30 bacteria present in a culture originally, how many bacteria will be present at the end of second hour, fourth hour and nth hour? If you just list out 2-3 terms, immediately you will realize it would be one of the standard progression, either AP or GP. So initially we have 30 bacteria. So here first term is A equals to 30. Then it would be double in every hour. So after 1 hour it will be 60. Fine. This is after 1 hour. So I'll call that as A1. After an hour. Then in next hour it will be 120. This is A2. Then again this will be here double of this, which is 240. That is A3. A3 means after third hour. Okay. Now what is asked? At the end of second hour. At the end of second hour means this much. Right. So at the end of second hour, which is how much? 120. You can see this is geometric progression. You might have noticed ratio is 2. Okay, after third hour, that is nothing but what? Here, acha, that is not asked. At the end of fourth hour. At the end of fourth hour. That is here A4. But remember, A will be this. This is your A because we have called this as A1. This will be your A. After 1 hour, it is this. So you can write directly from this, which is 480 here, double of this, which is 480, or you can use the formula also. Now what you want? At the end of nth hour. So at the end of nth hour, which is nothing but your A into R raised to n minus 1. What is A? A is 60 here. A is 60. We have started with this. This is at the end of first hour, that's why. This was initial, remember. So here you have 60. This is 60. Into R. R is 2. Ratio. This upon this, which is 2. 2 raised to n minus 1. At the end of nth hour you want. So this you can write 30 into 2 into 2 raised to n minus 1. Here n minus 1 and 1. So we'll get the 30 into 2 raised to n. Number of bacteria at the end of nth hour. Don't get confused with this A and this A. This was initial bacteria present initially. So this is actually initially means we can call as A0. I can write as A0 if you want. At the end of first hour, so this become the first term. This is second term, this is third term, this is fourth term, and so on. So this is nothing but indirectly what? A2. This is nothing but A4, as I told you. Right? And at the end of nth hour, that is this one. The next question, it's about interest. In fact, it's about compound interest. 500 rupees, that's the amount. It is deposited for 10 years at the 10% interest rate and compounded annually. The question is, what will be the amount at the end of 10 years? That's a question here. Okay, fine. So we have here initial amount equals to 500. Initial amount, that is how much? 500. Now at the end of first year, it will be 500 plus 10% of 500. 10% of 500. So you can just take 500 common here. So 1 plus 10% means 10 by 100, which is 1 by 10. So 500 into 1.1. This is 0.1. This is at the end of first year. Same way here, if I do at the end of second year, how I'll do this? That is, now amount is this 500 into 1.1 plus here 10% of your amount. Now amount is this 500 into 1.1. Fine, 10% of this. So you can find this much common. I'll take 500 into 1.1 common. What I'll get from this? This is 1 plus 10% means 1 by 10. So this is again 1.1. This is 1.1. So 1.1 the whole square. You can see that it forming a geometric progression. A into R square. So at the end of, now you can generalize, at the end of 10 years, it will be how much? It will be rupees 500 into 1.1 raised to 10. Right? No need to simplify. You can just keep it like this. I hope you must have realized at the end of second year it becomes square. This is like AR. This is like AR square. So this is like A into R raised to n. That is the basic formula here. Okay, so in such questions, if you write one or two terms, immediately you can answer here. Let's consider next question. If you read the question, you will see that AM and GM of the roots of a quadratic equation are 8 and 5. Okay, so we start with this. Let roots of the quadratic equation be A and B. Right? And therefore the equation will be this. You know what will be the quadratic equation? X squared minus sum of the roots into x plus the product of the roots. We know this from 10th standard. X squared minus sum of the roots into x plus the product of the roots. Okay, we want this equation. So you need a plus b and a minus b. Now what is given? You are given that am, that is equals to how much? 8, and gm equals to how much? 5. am means a plus b by 2 of the roots equals to 8, and therefore a plus b equals to 16. Geometric mean is root ab, which is 5 of these roots, so b equals to 25. This, and therefore by 1 you will get the required equation. By 1 required equation is x squared minus, what is a plus b? 16x plus 25 equals to 0. This is required equation.